Welcome to Easy Math. My name is Zishan, and this is the third video. This is the third video in the series of baseline worksheet questions that we are doing. We're now doing coordinate geometry. Question number 17. They say there's a straight line which has a gradient of 2. Okay, so it means the m value for the line is a 2. And it passes through the point 0, comma, -3. Find y equals to mx plus c happens to be the general form of of a straight line. Y and x, if we see if it passes through a 0, -3, y is a -3. Simply substitute a y equals to -3, m value of 2, and x equal to 0. You get yourself the value of c. 2 into 0 is a 0, 0 plus c, which means c is a -3. Now for the line, you have the m value and you have the c value. Y equals to mx plus c. Simply substitute the values that you have, and there it is, your equation of the straight line. Done. Put up the m value, find out the c value, substitute them back into the general form. You get yourself the equation of the line. That is it for the part 1. Let's look at the part 2. They say there is a point 4, comma, k that the line passes through. Find the value of k. Okay. Y equals to 2x minus 3. K is a y in this case, 2 times 4 minus 3. I substitute a x equal to 4. K comes out to be a 8 minus 3, a 5. There it is. K is a 5. Simply putting it across is y is supposed to be a k and x is supposed to be a 4 in your equation of the straight line. You simply substitute a 4 there and a k there, you get yourself the value of k. That's it. That was the 17th one. Let's look at the 18th one. The coordinates of the point are find the equation of the line passing through the origin and having the same gradient as AB. Okay, let's find out the gradient of AB. The formula is y2 minus y1 divided by x2 minus x1. Well, those are the y values and these are the x values. -3, 5, 2, and 1. I'd go -3 minus 5 divided by 2 minus 1 comes out to be a -8 divided by 1. That's a -8. Okay, so that's the gradient of AB, a -8. And they're saying it passes through the origin. Origin, it's supposed to be a 0, 0. Y equals to mx plus c, again, is the general form of an equation of a straight line. If it passes through the origin, y is a 0, m is a -8, x is a 0 because it passes through the origin, and c also comes out to be a 0. Well, in that case, y equals to -8x plus a 0 is the equation of the straight line, but plus a 0 you don't need to put up. C came out to be a 8. Y equals to -8x is your answer for the 18th one. Let's look at the 19th one now. So there is a line, equation of which is 3x minus 4y equals 24. Okay. It intersects the x-axis at A and y-axis at B. Given that M is a point 4, -3, find the gradient of the line L. Well, if this is the equation of the line, I can actually transform it, bring it to a y equals to mx plus c form, clearly seeing what m value and c value is. And that helps me find out the gradient because m that I get by transforming this is the gradient. Well, let's see. I'm going to try to make y the subject here, trying to transform it. -4y is supposed to be 24 minus 3x. Now multiplying both sides by a -1, trying to get rid of that -4. 4y is a 3x minus 24. That's multiplying both the sides by a -1. Y comes out to be 3x minus 24 by 4. Now let's separate them into fractions so that I can clearly see what the m value is. There it is. Y equals to m x plus 6. So m comes out to be a 3 by 4. That's a very nice trick to find out the gradient of the line L. Make y the subject. Try to bring it to the mx plus c form. Y equals to mx plus C form. There it is, your M value. Done. Length of A and B. Well, if y equals to 3x by 4 minus 6 happens to be the equation of the line, or it was a very nice 3x minus 4y equals 24, I can actually find out what points on the x-axis and what points on the y-axis is the line cutting through. How to find out the place where it cuts through the x-axis? For that, I'm going to substitute a y equal to 0 there. When you substitute a y equal to 0, x comes out to be an 8. And that's the usual way of finding out what the x-intercept is. Y-intercept, the place where it cuts through the y-axis. Well, you're going to substitute a x equal to 0, y comes out to be a -6. The coordinates of the points that the line cuts through are going to be 8, 0 on the x and 0, -6 on the y. Now, that is your point A, that is your point B. Now, they want us to find out the length AB. Well, the length AB is going to be root over y2 minus y1 square plus a x2 minus x1 square, comes out to be square root of, those are your y values, -6, -0 square plus a 0 minus a 8 square. It comes out to be 36 plus a 64. That's a root over 100. That's a 10. That's your length for AB. Done. Okay, now third part. The equation of the line passing through B having the same gradient as OM. Well, first, let's find out the gradient of OM. O is supposed to have coordinates of 0, 0. M is supposed to be 4, -3. The gradient would be -3 by 4, again using the formula y2 minus y1 upon x2 minus x1. Well, there it is. That's your M value for the gradient of OM. And the coordinates of B are 0, -6. If the coordinates of B are 0, -6 and the gradient of the line is supposed to be -3 by 4, the equation is going to be y equals to mx plus c always, where y equals to m value of -3 by 4 plus a c. Now you substitute the coordinates of B in there. -6 equals to -3 by 4 into 0 plus a c. C comes out to be a -6. Well, now we substitute a -6 in place of c. That's your equation for the line they have asked for. That's your part 3. Now let's look at question number 20. Find the equation of the line passing through A and B. Well, the coordinates of B, I can clearly see it's a 0, 3. For A, it's a -1, 0. And the line passing through AB, M value is going to be 3 minus 0 divided by 0 minus of -1. Y2 minus Y1, X2 minus X1, 0 minus -1. Remember, that's a mistake everybody may do. 3 divided by 1. 3 is the gradient you get here. And y equals to mx plus c again is the equation of a straight line. Y is equal to 3x plus c. Now we are going to find out the value of c by substituting the coordinates of one of the points. We substitute a 3 in place of y, a 0, and there it is, c equals to 3. Well, I need not find out the c value using what I have done here. I can actually see that the line cuts through the y-axis at 0, 3. Well, this is your x and y-intercept, no, 3. That's actually the c value always. C was a 3. You can clearly see it here. Of course, if you want to do it the equation way, you can actually. So y equals to 3x plus 3 is the equation of the line that we have here for the part 1. Now let's look at the part B, part 2, where they want us to find out the equation length of AB. Okay, length of AB is gonna be 3 minus a 0 square plus a 0 minus a -1 square. Square root of that is the length AB comes out to be square root of 9 plus 1. That's AB. AB comes out to be root over 10. Well, they've said that the length is a root over h, and find out h. I found out it to be root over 10. So h must be at 10. That is your answer for the part 2. Now let's look at another one. There is a point minus 5 comma k which lies on BA produced. Okay, I have the equation of the line, I think, y equals to 3x plus 3. I can substitute the coordinates of the point to find out the value of k. K equals to 3 into minus 5 plus a 3 comes out to be minus 15 plus a 3. It's a minus 12. That's your k value. Okay. Now they're saying that given that y equals to x plus 1 is the line of symmetry of the triangle ABC, find the coordinates of C. Okay. Well, for this one, no, you have to be a little intuitive. Only then will you be able to do. I'm going to have to take this across and zoom around it to make you understand how to do it. There it is. Take it here. Let's zoom around it. First, let's show you the line y equals to x plus 1. Y equals to x plus 1, the line is supposed to pass through these 2 points there. That's how it'll go. And they're saying that y equals to x plus 1, this line is a line of symmetry. First of all, if you're confused about why the line is what I have drawn there, you can actually create a table of values, x and y. Put a x equal to 0, you see y is a 1. Put a x equal to minus 1, you see y is a 0. So 0, 1 and minus 1. 0, 1 and minus 1, 0 happen to be the points that the line is going to pass through. Join these 2 points, extend the line on both the sides. You get yourself the line itself. Now they're saying that this line, y equals to x plus 1, is a line of symmetry for the triangle ABC. Okay. Well, it means that there is a triangle that they're trying to create there. And this thing happens to be the line of symmetry for it. Find the coordinates of C. Okay. So is there anything in specific? Find the coordinates of C. Okay. Well, there are many possibilities, but one of them happens to be right there. Okay, so there it is. A 2, 1. That's your C value. Again, what I did was a very simple thing. I drew a perpendicular from B onto the line of symmetry, and I extended it. I made sure that if this part of the perpendicular is in one box there, the other part is also diagonal to one box. And that's how I have that symmetry thing going. Ends up with a 2-1 on C. There are many other possibilities, by the way. You can actually go like that, I think. Yeah, that will also, oh no. That's the only possibility there. That's your C thing, a 2-1. Yeah, that's about it. C is a 2, 1. That's all you had to do. Let's look at question number 21. So this was supposed to be intuitive, this fourth thing. There can be a method for it, but we are not going to get into that. Okay, let's see. This happens to be trigonometry 21, but we do question number 22. That's also trigonometry 23. Okay, let's address the trigonometry questions also in this video only. Or maybe I'll do a separate one for this one. We go from 21, 22, 23 and on 24 in the next video. Enough for it. I'll see you, man. Bye-bye.